Hi, I'm an old guy and I do maths, and today we're looking at Newton's method, sometimes called Newton's approximation. And I guess the first thing that we need to do is we need to sort out what it's meant to do and, in fact, how we get to the point where it does that. So, what are we looking for? Well, we're looking for an approximation of the solution to a function of x. And because we're looking for an approximation, we are going to wind up with that. A very close approximation, but an approximation nevertheless. So, let's start with a function, a fairly simple one. And I've chosen 3x squared minus 4x. It's easy to factorize, and from the factors I can get the solutions. So we know that this is a solution. We're going to concentrate on this one. This is the derivative, 6x minus 4. So we're going to be dividing, a lot of the time, we're going to be dividing 3x squared minus 4x with particular values inserted into them by 6x minus 4. Now, this formula forms a sequence. And I want to talk about that a little bit before we start looking at the mechanics of this. So this sequence, for those of you who are unfamiliar with them, this sequence is formed by starting with a number here, which creates a new value. And that new value is this. And so xn plus 2 will equal xn plus 1 minus the function of xn plus 2 over the derivative of xn plus 2. That's basically how a sequence works. Okay, so let's have a look at what happens if we get a perfect solution to this. Now remember, we know about the perfect solution. And we know that the perfect solution is 4 over 3. We know we will get 0. Right, so if we insert 4 over 3 into this part of the equation, what we wind up with is 0, because this minus this is equal to 0. We don't have to worry about this. We get a fraction with a numerator of 0. Which means that because this was x, our operation actually looks like this. It is going to be 4 over 3 minus this, 4 over 3 minus 0, which will give us 4 over 3, which we know to be one of the solutions. Now, nothing ever works out as beautifully as that. What you're usually faced with is a whole series of numbers. Right, so let's have a look at the sequence, and we'll try a couple, and hopefully you'll get to see how this thing actually works. Right, so the sequence. More pieces of paper, I'm afraid. This takes a bit of explaining. So here's an extract of a sequence involving the function 3x squared minus 4x. Okay, and what I've chosen as my starting point is a very small number, 0.15, which you will see is quite close to 0. Now we know that one of the solutions for this is 0. And I just thought that this was a little bit easier to work with than to go hunting for 4 over 3. So, what happens? Well, the next number in our sequence is going to be generated by taking 0.15 and subtracting function of 0.15 divided by f prime of 0.15. Now here are the numbers. So that's 3 times 0.15 squared minus 4 times 0.15 all over 6, we'll put the derivative in there, 6x minus 4, 6 times 0.15 minus 4. And what we get is we get this very small number. So we started with this number, 0.15, and we are getting closer to 0, which we know to be one of the solutions. We take this number and we generate a new number with it. This really is just sequences. Here's that number here, and from that we are going to subtract this unholy looking mess, which is 3 times x squared. X is negative 0.021774194 squared, minus this divided by this. And look what happens. We're getting an even smaller number. What we are having happen is this is tending to 0, which is one of our solutions. Now, if I wanted to, I could put in a number close to 4 on 3. So what's a number close to 4 on 3? I'm not going to do this, but if I take a number close to 4 on 3, what would be a good one? Let me think. So that is, we'll do this as a decimal actually. So that's 1.3 recurring. So if we took 1.5, just for a tiny bit of symmetry, as we use 0.015 here, if we took 1.5 and put it through this process, we would get a result that is closer to this than 1.5 is. And we would just repeat the process and we would get endlessly closer to this thing, possibly until our calculator ran out of decimal points to use. Mine's got 10 decimal points, so I'm well on the way to running out of space. But what you will see is that the number that I'm approaching is tending to 0, and it's getting very, very small. That's a result that I'm pretty happy with. So I hope that this made a bit of sense to you. It's not the sort of thing that you undertake lightly. It's usually tucked away in textbooks as a bit of an interesting exercise. In fact, I think in the last couple of years it's really the first time that I've seen it turn up in sort of general high school maths. Sometimes it turns up in advanced maths. I've seen it in you see this in engineering courses. That's generally where I see it when I tutor people who are doing maths for engineering. Anyway, I should just stop here, I think, while we're ahead, and we'll call it a day. I hope you found this useful. I hope you found it helpful. If you did, please like and subscribe, and I'll see you next time. Bye.